This video is going to take you through several things to do with electrolysis. First of all, we'll cover the basics. After this, we'll start having a look at electrolysis with given examples of molten ionic substances. I'll then look at electrolysis in aqueous solutions before finishing off with the two examples that you need to be aware of. First one being electrolysis of sodium chloride solution, and second being the extraction of aluminium from its ore using electrolysis. When you get an electrolysis question in an exam, the first thing that you should do is have a look at the common ion chart on the back of your periodic table. This data sheet is given to everybody in their chemistry exam. What is electrolysis? It's the breakdown of an ionic compound into simpler substances, often the elements that it's made up of, using electricity. So that's the breakdown of an ionic compound into simpler substances using electricity. Electrolysis involves a cell. The cell is made up of a beaker with two electrodes connected to an external power supply. One of the electrodes will be positive and one of them will be negative. In the beaker there will be an ionic compound which has either been melted or dissolved. The reason why they're melted or dissolved is because the ions need to be able to move in the solution or the liquid in order for them to conduct electricity. When the circuit is complete and the power supply is on, the negative ions will move towards the positive electrode and the positive ions will move towards the negative electrode. In ionic compounds, the metal ions are positive and the non-metal ions are negative. There is one non-metal ion that is also positive, and that's the hydrogen ion. This becomes important when you are doing electrolysis using solutions rather than molten ionic substances. Typical exam questions can ask you which electrode is an ion going to go towards and why. So for example, chloride ions, which electrode will the chloride ions go towards? They will go towards the positive electrode. And the reason behind this is because opposite charges attract. When you melt an ionic compound, for example magnesium chloride, it will become a liquid. In that liquid you will have magnesium ions which are now free to move, and you will also have chloride ions which can move. Now when you put this through an electrolysis experiment, the magnesium ions will go towards the negative electrode and the chloride ions will go towards the positive electrode. What happens to the ions when they reach the electrode depends on the charge of the ion. Both magnesium and chloride ions, when they reach the electrode, will turn back into atoms which have no overall charge. Positive ions, this is slightly easier. Mg2+, to have no overall charge, needs to gain 2 electrons. If you look at it, Mg2 plus electrons. Cl minus, we are going to minus electrons. Now because it's Cl minus, that means it only needs to lose 1 electron. That will then make it a chlorine atom. That's only part of the story here. So chlorine atoms don't exist by themselves, they exist in pairs. So it's Cl2. That will mean that we need 2 chloride ions. Each chloride ion loses an electron, so there's a total of 2 electrons being lost. We don't leave it in this particular way because we only like to have plus in our ionic equation. So we have 2 Cl minus goes to Cl2 plus 2 electrons. So what we've done is we've moved this over to this side, and in doing that we've had to alter the sign here. So this is one half equation and this is another half equation. Now we can classify each of these half equations as either oxidation or reduction. We can use the oil rig method. Oxidation is loss of electrons, reduction is gain of electrons. So in the magnesium situation, they have gained electrons, therefore this is reduction. In the chloride example, the chloride has lost electrons, therefore this one is oxidation. Electrolysis of a solution becomes a little bit more tricky. Because it's a solution, it's been dissolved in water. This then means the magnesium chloride is now aqueous. We don't just have magnesium ions and chloride ions. We also have hydrogen ions from the water and hydroxide ions from the water. So we've got 2 positive ions and we have 2 negative ions. Only one ion will go to each electrode. So there has to be a decision made as to which ion is going to go to each electrode. They tend to only ask you questions about the positive ions, so I'm going to focus on the positive ions here. You need to have a look at your reactivity series, which is again on the back of your periodic table on the data sheet that you will get in your exam. What you need to do is have a look for magnesium and have a look for hydrogen. The one that is the least reactive is going to go to the negative electrode. So in this example, it's the hydrogen. Magnesium will remain in solution. So hydrogen ions go to the negative electrode. When the hydrogen ions reach the negative electrode, because it's a positively charged ions, so it's a plus charge, we will plus electrons. Now this will make hydrogen atoms. But again, hydrogen's a non-metal atom. They don't go round by themselves, they go round in pairs. So it's H2. This will mean that we'll have 2 H plus ions and we will need 2 electrons, one to be added to each of the hydrogen ions. This has gained electrons, therefore this is another example of a reduction reaction. Electrolysis of sodium chloride solution is one of the examples that you need to be aware of. Formula of sodium chloride is NaCl. Because it's solution, it will be aqueous. This will mean you will have sodium ions and you will have chloride ions, but because it's aqueous, you will also have hydrogen ions and hydroxide ions. So, what are our products? What's going to go to the electrode? In the example of the positive ions, it's the least reactive that goes to the electrode. So that's going to be hydrogen. When the hydrogen gets to the negative electrode, it's a plus charge. It will add electrons and it will form hydrogen atoms. These will pair up to give you hydrogen gas. So there's our equation. That's reduction. At the negative electrode, we have a halide ion. Now, a halide ion is a halogen that's an ion. So halogens are group 7. So this is chloride. Chloride ions will go to the positive electrode. They go there because they are negatively charged. The chloride ion, when it gets there, because it is negatively charged, will lose electrons and become chlorine atoms. But again, non-metal atoms don't go round by themselves, they go round in pairs, so we'll need 2 chloride ions and 2 electrons. Don't like this over this side, so we have 2Cl minus goes to Cl2 plus 2 electrons. So some of the key things here are the fact that hydrogen is the product at the negative electrode and that chlorine is a product at the positive electrode. So you will need to know what is produced at each electrode for sodium chloride solution. This has left us with Na plus and OH minus ions still in solution. Well, they remain in solution, and what they will produce is sodium hydroxide solution. So they will stay in solution. So that is the third product of electrolysis of sodium chloride solution. So our 3 products are hydrogen gas at the negative electrode, chlorine gas at the positive electrode, and sodium hydroxide in solution. You need to be aware of some of the uses of these 3 products. So it's probably best just to try to remember one of them. You're unlikely to get 2 marks to give 2 examples of the same particular product. So hydrogen gas is used to make margarine or ammonia. You decide which one you're going to remember. Chlorine gas or chlorine, the easiest one to remember, is potentially killing bacteria in swimming pools, just because that's something that you're already aware of. And then sodium hydroxide solution is used in the manufacture of soap. Aluminium is a very useful metal. It needs to be extracted from its ore using electrolysis because it's more reactive than carbon, so it can't be displaced. One of the problems is that aluminium oxide is insoluble in water. So in order to extract it using electrolysis, the ions still need to be able to move. You'd have to melt it. Because it's an ionic substance and the ionic bonds are very, very strong, its melting point is very high. Therefore, in order to lower the energy requirements, it is dissolved in a substance called cryolite. This lowers the melting point of aluminium oxide, and then it lowers the energy cost, so it makes it cheaper. The ions that are then involved in electrolysis are Al3 plus and O2 minus. These are the only ones that you need to be concerned with. Aluminium is going to go to the negative electrode and the oxide ions are going to go to the positive electrode. Notice that non-metal ions have a different name to their element, so oxygen produces oxide ions. Now when they reach the electrodes, aluminium ions, because they have a 3 plus charge, pluses or adds 3 electrons. This then makes aluminium metal. Because it's gained electrons, it's an example of reduction. Oxide ions are negatively charged, so you minus electrons. Here we have 2 electrons per oxide ion. This will then make oxygen atoms. Once again, oxygen atoms, non-metal atoms, don't go round by themselves, so they go round in pairs. This will then mean we need 2 oxide ions, and rather than losing 2 electrons, we actually lose 4 electrons. We don't like these on this side, so the whole equation then looks like this. Because it's lost electrons, this makes this particular one oxidation. Oxidation is loss, reduction is gain. There's another extra that you need to be aware of with extraction of aluminium from its ore. The electrodes are made of graphite. Graphite is a non-metal, but it does conduct electricity because it has free electrons that move between the layers of graphite due to carbon only having 3 out of the 4 possible bonds. This part of the electrolysis cell is the negative electrode. So all of this is the negative electrode. That means the aluminium ions are going to be attracted here. Now there'll be a space where the metal is tapped off down here because it will be molten with this happening at such high temperatures. The oxide ions are going to go to the positive carbon electrodes. Now once again, because the temperatures are high, once these oxide ions get there and they make oxygen gas, these electrodes are made of carbon. So the carbon that the electrodes are made up of will react with the oxygen gas that has been produced at the positive electrode. This will then give off carbon dioxide. What this means is that over time the carbon electrodes will get smaller and smaller as this carbon has reacted with the oxygen gas. This will then mean that these electrodes need replacing. Again, this is a favourite exam question where they ask you why the carbon electrodes need replacing. The reason is because the oxygen gas reacts with the carbon electrodes to produce carbon dioxide, so they wear away over time. So that concludes electrolysis. If you are in my class and you would like to ask me any questions or any clarification about that, then please come and find me. If not, key points: positive goes to negative, negative goes to positive because opposites attract. Oil rig, oxidation is loss, reduction is gain. If you have a molten liquid, things are a little bit more simple. Positive metal ions go to the negative electrode, negative non-metal ions go to the positive electrode. If you've got an aqueous solution, it gets a little bit more complicated. You've got the addition of hydrogen and hydroxide. The positive ions in particular are important. It's the least reactive one that will go to the electrode. The other will just stay in solution. Thank you for watching.